Hi everyone, today we will discuss about the igneous textures. First of all, what is this igneous rocks? Igneous rocks can be defined as those rocks which is formed by the consolidation of magma or lava, and it is a crystalline or a glassy rock that forms from the cooling of this magma. A magma consists mostly of liquid rock matter, but may contain crystals of various minerals and volatiles. And igneous rocks can be classified into two types as extrusive igneous rocks and intrusive igneous rocks. Extrusive igneous rocks are those rocks which is formed by the consolidation of magma at the earth's surface, while the intrusive igneous rocks are those which is formed by the consolidation of magma at a greater depth. Now we are going to discuss about the textures. So the textures can be defined as the mutual relationship of mineral constituents and a glassy matter in a rock made up of uniform aggregates. Now the important use of the texture is that it provides direct evidence about the origin of rock and always forms a part of the rock description. Now the main factors that determine the texture of an igneous rocks are: the first one is the cooling rate, the second one is the physical conditions during the emplacement of the magma, the third one is the diffusion rate, and the fourth one is the rate of growth of crystals, and the last one is the rate of nucleation of crystals. So these are the five main factors that causes the determination of a texture of an igneous rocks. Now we will discuss about what are the accurate determination of the igneous textures needs, which are the factors that contribute to the defining the texture of an igneous rocks. There are four main factors. The first one is crystallinity, then granularity, the third one is shape of the crystal, and the fourth one is the mutual relationship of crystal and glassy matter. So based on these four factors, the texture of an igneous rock can be explained. In here, the shape of the crystal and the mutual relationship of crystal and the glassy matter is together known as fabric. So for explaining the texture of an igneous rock, crystallinity, granularity and the fabric need to be explained. So the first one is crystallinity. Crystallinity can be defined as it is the ratio which is existing between the crystallized and the non-crystallized matter in a rock, and the crystallinity is affected by the rate of cooling and the viscosity of the magma. So the rate of cooling and the high viscosity favors the formation of glass, whereas slow cooling and the low viscosity favors the formation of crystals. So on the basis of crystallinity, three textures are defined in igneous rocks. They are hollow crystalline, hollow hyaline and merocrystalline. Hollow crystalline is a texture in which if the igneous rock is composed entirely of crystals, then that texture is then igneous rocks can be defined as then hollow crystalline. If the rock is composed entirely of glassy matter, then the rock is termed as hollow hyaline. If the rock is composed partially of glass and crystal materials, then the rock can be termed as merocrystalline. So the example of hollow crystalline are the plutonic igneous rocks like granite. For the hollow hyaline are the volcanic igneous rock like basalt or obsidian. For the merocrystalline, the rock is dolerite. So based on the crystallinity, igneous textures can be defined in this manner. Next we will move to the granularity. So granularity refers to the absolute size of the crystals, and on the basis of granularity, the igneous textures are two types. We have phaneric rocks and we have aphanitic rocks. Phaneric rocks are those rocks in which if we can see the individual crystals with our naked eyes, then that type of rock is known as phaneric rocks. Aphanitic rocks are those rocks in which we cannot see the individual grains with our naked eyes. We need the help of microscope. So in the phaneric rocks, since we can see the individual grains, on the basis of their individual grain sizes, the phaneric rocks have been again divided into three types as coarse grained, medium grained and fine grained. Coarse grained are those crystals which is having a diameter greater than 5 millimeter, and medium grained crystals are those which is having a diameter in between 5 to 1 millimeter, and fine grained igneous rocks are those which is having a crystal diameter less than 1 millimeter. Now the aphanitic rocks are those in which the individual crystals cannot be distinguished by our naked eyes. So again, these aphanitic rocks are also been divided like that of the phaneretic rocks. Here aphanitic rocks has been divided into microcrystalline rocks and the cryptocrystalline rocks. In the microcrystalline rocks, the individual crystals can be identified with the help of microscope, but in the cryptocrystalline texture, the individual crystals cannot be viewed through with the help of microscope. So this is all about the granularity. Now here in this diagram you can see the phaneric and aphanitic rocks. As you can see, the phaneric rock, the individual grains can be, we can use the hand lens and we can simply identify the minerals that is present in the phaneric rocks. But in the aphanitic rocks, since it is very fine grained, we cannot, the individual minerals cannot be visualized through our naked eyes. We need the help of microscope. Now on the basis of shape of crystals. On the basis of the shape of the crystals, we can divide the textures into 3 types based on the crystals, that is euhedral, subhedral and unhedral crystals. Euhedral crystals, if the individual crystals present in the igneous rocks are having basic shapes, then we known as well developed faces, we call it as a euhedral crystal. If the individual crystals are partially developed, then we call it as a subhedral phases. Then if the individual crystals does not have any shape, then we call that as unhedral or xenomorphic crystals. So that's the terms which we give to an igneous rock, which based on their shape of the individual crystals. Now as you can see it in this figure, we are giving the images of the euhedral, subhedral and unhedral crystals of olivine that is crystallizing here. And the first figure we can see the faces of the olivine crystals are well developed, but in the second figure it is subhedral, that means partially developed. In the third figure it does not have any shape, that's why it is called as unhedral. Now the next one is the mutual relationship of crystal and the glassy matter. So on the basis of the mutual relationship or the pattern of crystal arrangement, different types of textures are present in igneous rocks. So they are, the first one is equigranular texture, inequigranular texture, seriate texture, directive texture, intergrowth texture, and the last one is interstitial texture. So we look into each one by one. The first one is equigranular texture. Equigranular textures are those textures in igneous rocks. If the majority of the grains are of equal grain size, then we call that rock as having equigranular textures. So on the basis of the shape of the crystal plus the equigranularity, the textures of the igneous rocks are divided. That is, if the equigranular igneous rock having euhedral shape of the crystals, then that texture is known as panidiomorphic texture, which is shown by the typical rock, that is lambrophyre. Now next one is hypidiomorphic texture. Hypidiomorphic texture is shown by an equigranular rock which is having subhedral shapes of crystals. An example is granite. Then allotriomorphic texture. Allotriomorphic texture has been shown by an equigranular igneous rock which is having unhedral shapes of crystals. So these are the classification of igneous rock textures on the basis of equigranularity and the shape of the crystals. Now the next texture is the inequigranular texture. So as the term implies, in inequigranular texture we can see the shapes of the crystal and the size of the crystal are of different size. We can see larger crystals and we can see smaller crystals. So that type of texture is known as inequigranular texture. So there are different types of inequigranular textures are there. The first one is porphyritic texture, we have poikilotic texture, interstitial texture and seriate texture. So we can see the first one, that is the porphyritic texture. Porphyritic texture is a type of inequigranular texture in which the larger crystals are surrounded by smaller crystals. and the larger crystals are termed as phenocryst and the smaller crystals are termed as ground mass. As you can see it in this figure, the larger crystals are shown in the ash color while the dark grains consist of the ground masses. Now, in this porphyritic texture, if the phenocryst is surrounded entirely by glassy material, then the texture is termed as vitreophoric texture, and if the early formed crystals of olivine, pyroxene and plagioclase that are gathered in distinct clusters, then it is called glomeroporphyritic texture. So, there are different varieties of porphyritic texture. The first one is vitreophoric texture, then we have glomeroporphyritic texture. Next we will discuss about the important inequigranular texture, that is the poikilotic texture. Poikilotic texture is another important type of inequigranular texture. Here what happens is that the smaller crystals are enclosed within the larger crystals, and the larger grains are known as, here they are oikocryst, and the smaller crystals are known as chadacryst. So, this is a type of poikilotic textures, and there are different varieties of poikilotic texture, and the first one is the ophitic texture. Ophitic texture is a special type of poikilotic texture in which the augate mineral encloses the plagioclase laths, which is typically seen in the intermediate igneous rock like dolerite. And the next important type is subophitic texture. Here the enclosement of augate and the plagioclase is partial, which is seen in gabbroic rocks. And the next important variety of poikilotic texture is hyalophytic texture. It is a special type of ophitic texture. Here the difference is that the plagioclase are completely surrounded by glassy materials. So, these are the important varieties of poikilotic texture. They are ophitic texture, subophitic texture and hyalophytic texture. Now, this is the diagram which indicates the poikilotic texture and ophitic texture. As you can see it in this figure, the larger grains of the pyroxenes are enclosed by the plagioclase laths, and on the ophitic texture we can see that the pyroxene is typically augate. In that augate we can see the laths of the plagioclase are enclosed, and that is typically seen in the rock dolerite, which is an intermediate hypobasal igneous rock. Now, the next important type of inequigranular texture is the serrate texture. Serrate texture is a type of texture in which we can see clusters of the same mineral present within the rock. If that is seen, then that texture is known as serrate texture. As you can see it in this figure, the plagioclase crystals of larger and smaller size and of different sizes are seen as clusters within this rock, and that texture is known as serrate texture. Then the next important type of inequigranular texture is the interstitial texture. Now, the interstitial textures are those textures which are formed by the association of plagioclase laths. We know that the arrangement of plagioclase laths in wedge-shaped manner, and because of its wedge-shaped manner, the different interstitial textures are there. There are two varieties of interstitial texture. The first one is the intergranular texture, and the second one is intersertal texture. Intergranular texture is a type of interstitial texture in which, when the plagioclase laths are arranged in a polygonal manner, there will be spaces, interstitial spaces are there. These interstitial spaces have been filled with pyroxene crystals and olivine and pyroxene crystals, then that texture is known as intergranular texture. And if that interstitial spaces are filled with the glassy material, then the texture is termed as intersertal texture. So, here the diagram, the figure shows the intergranular texture and the interstitial texture. As you can see it here, in between the plagioclase laths, you can see the pyroxene augate is present in between that interstitial spaces, hence it is termed as intergranular texture. While in the intersertal texture, you can see that plagioclase crystals are arranged in the wedge-shaped manner, while in between them we can see the glassy matter which is present in between these spaces. So, this texture collectively called as interstitial texture, and which is divided into intergranular and intersertal textures. So these are the important inequigranular texture, that is already we have said that. Now we are moving to the intergrowth texture. Intergrowth textures is a type of texture in which the two minerals shows the interpenetration pattern, which means if this is one mineral, this is another mineral, these two minerals shows interpenetrative pattern of arrangement, then that type of texture is known as intergrowth texture. And there are different types of intergrowth texture, and the most important aspect about the intergrowth texture is that it shows that magma undergoes simultaneous crystallization, in which the two minerals are crystallizing together, and due to that formation this interpenetrative pattern has been formed. There are different types of intergrowth textures are there: graphic texture, perthite and antiperthetic texture, sympathetic texture, and myrmecite texture. So we can first go through the graphic texture. So graphic intergrowth. So graphic intergrowth is a type of intergrowth texture which has formed by the association of quartz and alkali feldspar. So this intergrowth is known as graphic intergrowth, and this texture resembles the cuneiform writings, and if this graphic texture can be visible through our naked eyes, we call it as it is graphic. But this, if we can see this texture only within the microscope, we call this texture as micrographic. So this figure simply shows what this graphic intergrowth is. As you can see, the dark shaded is the quartz, and the rest of them is microcline, is a member of alkali feldspar. So these quartz and alkali feldspar has been interpenetrative in each other, which represents the graphic texture. So the next important intergrowth texture is perthite and antiperthetic texture. These two common type of textures are seen in the granitic rocks, and the perthite is intergrowth in which the host mineral is potash feldspar. Here the host mineral is potash feldspar. Within this potash feldspar, what happens? Plagioclase minerals are intergrowing. So if the host mineral is potash feldspar and the intergrowing mineral is plagioclase, then this texture is termed as perthitic texture. Now the typical opposite is the antiperthetic texture, which means that the host is plagioclase and the intergrowing mineral will be potash feldspar. So this texture is known as antiperthetic texture, and this is typically seen in granitic rocks. So this is a diagram which typically shows the perthite texture and the antiperthite texture. As you can see it here, the alkali feldspar, that is a microcline. Within that microcline we can see the plagioclase crystals are growing, which means perthitic texture. And in the antiperthetic texture we can see that the plagioclase, in that plagioclase the orthoclase of potash feldspar are growing, which means it's showing antiperthetic texture. Now the next important type of intergrowth texture is a sympathetic texture. This sympathetic texture is also an intergrowth texture, but the only difference is that in a sympathetic texture, one of the mineral will be vermicular in nature. Vermicular means that mineral should have a worm-like appearance. So that type of intergrowth texture is known as sympathetic texture. And an important variety of this sympathetic texture is the myrmekitic texture. Myrmekitic texture is an intergrowth texture formed by the intergrowth between quartz and plagioclase feldspar. Here the vermicular nature is shown by the quartz. So this diagram will typically indicates the sympathetic texture and myrmecite texture. As you can see it in the sympathetic texture, the garnet has been surrounded by the worm-like spinel minerals, and in the myrmecite texture you can see that the quartz mineral, which is worm-like quartz mineral, which is been intergrown in the plagioclase feldspar. So these are the important type of intergrowth texture: graphic, then we move to perthite, antiperthite, then we have seen the sympathetic texture, then the last one is myrmicate texture. Next we will discuss about the overgrowth textures. As the term says, it is overgrowing, which means that a single mineral is there, and into that single mineral another mineral of the same composition or having different material will be overgrowing into that mineral, and that type of texture is known as overgrowth texture. And there are different types of overgrowth texture. The first one is the corona texture, and the second one is the crystal zoning. Now we are going to discuss about the corona texture. Corona texture is another important type of overgrowth texture, in which when a crystal of one or mineral is surrounded or rimmed by one or more crystals of another mineral, then the texture is termed as corona texture. And this texture is generally formed as a result of incomplete reaction of the inner mineral with the fluid or melt. As you can see, this is the inner mineral. Around this inner mineral, the new mineral has been overgrown, and that texture is known as the corona texture. And there are two types of corona textures are there. The first one is the Rapakivy texture, and the next one is Keliphitic texture. Rapakivy texture is that if the inner mineral is potash feldspar and it has been rimmed by sodic plagioclase, then the overgrowth corona texture is known as the Rapakivy texture. And if the inner mineral is olivine or garnet, this has been overgrown by the fibrous mineral like pyroxene or hornblende, then that texture is known as Keliphitic texture. Now this is a typical diagram which indicates the overgrowth corona texture, which means the sillimanite which is seen as the needles, that has been surrounded by the sapphire crystals. So it's a typical example of corona texture. Now the next important type of overgrowth texture is zoning. Zoning is a texture in which from a single crystal we can see there are different zones can be seen, and within that zone we will have slightly different composition of associated minerals. As you can see it in this figure, there is a rounded crystals that is been zoned can be seen of plagioclase feldspar, and in that plagioclase feldspar the inner composition and the outer composition varies. That variation is from calcium to sodium concentration. So the zoning is typically exhibited by solid solution minerals. The next one is directive textures. As the term says, this is particularly showing a direction. So these textures indicates that the minerals are arranged in the parallel manner, that is typically based on the direction in which the magma has flown. Now the important directive textures include trachytic texture and the trachytoid texture, and there is a slight difference in between these two textures. In both these textures we can see the parallel arrangement of feldspar grains. If we can see through our naked eyes, then the texture is known as trachytoid texture. If we cannot see through the naked eyes that the parallel arrangement of feldspar, then the term we use is trachytic texture. Both are included in the directed textures. So this is a typical figure that indicates the parallel arrangement, subparallel arrangement of potash feldspar, and it indicates the direction of the flow of magma. This is a typical trachytic texture. Now the next one is radiate texture, which means that the mineral grains are radiating towards a particular point, and here it is mainly shown in fine grained rocks. And the important radiate textures indicate spherulitic texture and variotilitic texture. Spherulitic textures are those textures in which the minerals are radiating from a center nucleus, and that type of texture is known as a spherulitic texture, in which here the interspaces are filled with glass or crystalline materials. In the case of variotilitic texture, it is also a radiate texture. Here the plagioclase feldspar are diverging from a particular point, and the arrangement is fan like manner, and here the intervening spaces are filled with the pyroxene, olivine or the iron minerals. So this is about the radiate textures. Now we conclude with some of the important miscellaneous textures. The first one is myrolytic texture, then we have lithophysa texture, orbicular texture and the spinifex texture. In the myrolytic texture, here we can see the irregular shaped cavities, and in that irregular shaped cavities we can see euhedral shaped crystals will be projected out. Then that type of texture is known as myorrhiztic texture. Then in the case of lithophysa texture, here this is also a cavity variety of cavity texture in which the interspaces are not being filled with particular minerals. Now in the case of orbicular texture, it consists of spherical orbs, and in that orbs what happens is that the minerals like fibrous minerals are arranged within that particular orbs, and that texture is known as orbicular texture. Now coming to the spinifex texture, this is an important texture which is mainly seen in the cometate magma. Here we can see the crisscross arrangement of olivine, especially magnesium olivine or aluminous pyroxene, that are crisscrossly arranged, and in between them we can see either the skeletal pyroxenes or glassy matter. This texture is very important texture which is mainly seen in the cometate magmas. So these are the important igneous textures we need to be understand when we are observing the igneous rocks. Especially the textures is mainly one of the important point which when we are dealing with the origin of the rocks, and the textures can be defined on the basis of the mutual relationship between crystals and the glass. On a conclusory note, we can say that igneous textures can be explained on the basis of granularity, crystallinity, and the shape of the crystal and the mutual relationship of the crystal, and the shape of the crystal and the mutual relationship of the crystal can be together called as fabric. So on the basis of that we have defined the different types of textures are there. So these all textures are very much important in identifying the origin of igneous rocks. Thank you.